Okay, so let's see the next business scenario and how to implement loops smartly in that particular business scenario. So now let's consider that again someone is investing rupees 5,000, let's say, for say 5 years, and the person wants to go for this quarterly mode of interest. So we have to find out the earning at the end of every year when the interest mode is selected as quarterly. I repeat, for the same rate of interest 4.5%, let's say there's a person who is investing rupees 5,000 for 5 years, but he's going for the quarterly mode of interest. We have to calculate the interest earned at the end of every year, meaning we have to calculate interest earned at the end of year 1, 2, 3, 4 and 5. So let's see how to implement this. In this particular scenario, we'll need to implement nested loop. So we'll see how to specify a loop within another loop and create a nesting of loops to handle such kind of complex business scenarios. So I'll write a data step where I'm going to implement multiple loops. So I'll implement a loop within another loop, that is called as nested loop, to achieve this business solution. So I say data nested loop okay, then I say do year is equal to 1 to 5. So the person is investing rupees 5,000 for 5 years. So I say do year is equal to 1 to 5 capital plus 5,000. But the person has selected the interest mode as quarterly. But we have to compute this. We have to write this interest earned at the end of every year when selected in quarterly mode to our output data set. So I say do year is equal to 1 to 5 capital plus 5,000. Then I say do quarter is equal to 1 to 4. I say capital plus capital into 0.045 divided by 4. Then I say end to end my inner loop. Then I say end to end my outer loop. And then I say run. Now since I wanted to write this interest earned at the end of the last quarter as the yearly interest, so just before I close this outer loop, let me write explicit output, which will ensure that the interest which is calculated at the end of fourth quarter is written as yearly interest. So at the end of first year's fourth quarter, second year's fourth quarter, third year's fourth quarter, fourth and fifth year's fifth quarter, whatever interest is calculated, that is written to my output data set. So this is going to write 5 observations for 5 fourth quarter interests which are calculated. So as you see, my output data set has 5 observations and 3 variables. I say proc print data is equal to nested loop, then I say run. So this is what it has computed. we can drop the second index, that is quarter, to avoid any misinterpretation of the data. So I just say drop is equal to quarter. I want to write the year value but not the quarter values. So this is what I'm getting. So at the end of first year, this is the earning. At the end of second year, this is the earning. At the end of third year, this is the earning. This is fourth year and this is fifth year. So at the end of fifth year, the person is going to get 28,649.15 rupees. Here we have written this output, explicit output, to write the interest calculated at the fourth quarter of every year as a yearly interest. In case if you are asked to calculate the interest earned at the end of every quarter, not just fourth quarter that we were considering as the yearly interest, but it has been asked to to write this interest earned at the end of every quarter. In that particular case, you'll have to shift this output in your inner loop. So earlier it was writing 5 observations for 5 years. Now it is going to write 20 observations for 20 different quarters. Okay, so you have 5 years meaning 20 quarters. So this is going to create 20 observations in my output data set. So if I execute this code, and proc print this, this is how it is writing the 20 prepared observations. So if you remember, earlier it was writing only 28,649, but now this is how it is writing the interest calculated at the end of every quarter. If we write output at both the places, in our inner loop as well as outer loop, in that case it is going to write this for 5 years and 20 quarters, that is 25 observations. And if you observe, if you compare the interest earned at the end of fourth quarter and interest earned at the end of first year, that would be exactly identical. The interest earned at the end of 8th quarter and second year would be same. 12th quarter and third year would be same. 16th quarter and fourth year would be same, and 20th quarter and fifth year would be same. Because that because the fourth quarter, 8th quarter, 12th quarter, 16th and 20th quarter interest we are writing as the yearly interest. That's the reason why they'll match with this year 1, 2, 3, 4 and 5. So let's investigate this output. So as you see, it is writing 25 observations and 2 variables in my output data set. And if you observe these values, so if you see the fourth quarter's interest, that is 5228.83, and the fifth observation, that is the first year's interest. So this fourth quarter and first year are same. Similarly, if you see the 8th quarter, okay, this 9th observation and 10th observation. 9th observation is the interest calculated at the end of fourth quarter of second year, and this is the second year. if you see these two values are same. Similarly, if you see this 19th and 20th observation are same, and 24th and 25th observation are same, because what earlier you were writing that fourth quarter as the interest earned at the end of year 1 and eighth quarter was interest earned at the end of year 2 and all, same you are printing in quarterly mode also. That's the reason why that fourth quarter and first year and that eighth quarter and second year, these values will match. So this is how you implement nested loops in SAS environment. Now we'll see one more demo on loop, and with that we are done with all possible examples on loops. So we have a data set in our library PRG2. Let's proc print the data set. Its name is banks. So I say proc print data is equal to run.banks, and I say run. Clear this output window. The log window and execute this proc print. So if you see this is what I have in my input data set. I have three bank names and there are three interest rates given. We'll implement the previous scenario now with respect to this data set. So let's say with this changing bank name and this changing rate of interest, what is the earning at the end of fifth year considering this rates of all these three different banks, and we have to find out the earning at the end of fifth year when invested in these three different banks, with these three different interest rates. So now we'll modify, or we'll write a new code where we are going to use this as input data set, and we are going to calculate the interest earned at the end of fifth year when invested same amount in three different banks which are giving three different interest rates. So we say data banks int, you can write any data set name, then I say set ran.banks, then I say do year is equal to 1 to 5, capital plus 5,000, do year is equal to 1 to 5, capital plus 5,000, and then I say do quarter is equal to 1 to 4, capital plus capital into 0.045. Then I say end output and again. Now since we are reading this dataset banks, this dataset banks has a variable by the name rate. So here we'll write, instead of 0.045, we'll write rate because this rate values are changing. I'll say rate divide by 4. So capital plus capital into rate divide by 4. Okay, suppose this is the case now. Capital plus capital into rate divided by 4. I say run now. Execute this code. One more thing that I need to implement in this code, if you see, when this 5,000 is invested in first bank for 5 years and interest is calculated, and after that when it is going and reading the second observation, I don't want the previous earning to be carry forward for this second bank, meaning I want to reset this capital amount and ensure that again my calculation starts from beginning. I don't want to consider the interest earned for the first bank at the end of 5th year and use that particular amount to calculate the interest earned at the end of 5th year for second bank. So I must ensure that before I start iterating the years and quarters, I set the capital to 0. So this is very important statement where you are saying capital is equal to 0, because this time, unlike previous scenarios where the amount was invested in the same bank, here the amount is invested in 3 different banks which are giving 3 different interest rates. So this capital is equal to 0 is very important. Without this, you will not get the correct output showing the earning from the second bank and the third bank if the first bank's earning is carried forward and used while calculating the earning from second bank and third bank. Now execute this. There is a space between 2 and the stop value. So it's reading 3 observations from your input dataset and writing 15 observations and 5 variables in the output dataset. Let me drop the quarter variable and write only year. So I say drop is equal to quarter. Now instead of writing the earning at the end of every year, that is 5 years for each bank, we can take this output and write only the earning at the end of 5th year for all 3 banks. So we can shift the output here to ensure that only the last year's earning is written for every bank. So I'll execute this once again so that only 3 observations are written, and then I say proc print data is equal to banks int from let me drop the year also, because as you see year value is printed as 6. One more thing, while describing the business scenario we said 5,000, but by mistake we had written 50,000 here. Let's make it 5,000. That's one. Another, I want to drop year as well as quarter. So I say drop is equal to year as well as quarter. So if you see, this is the earning from all three banks at the end of 5th year. So this bank, which is giving this interest rate 0.0318, from this bank this is the earning, from this bank this is the earning, and this is the earning from the bank which is giving you the highest rate of interest, that is 27,603. So if you compare this particular example, this demonstration or this business scenario with previous, in previous there was some amount which was invested for 5 consecutive years and the mode of interest selected was quarterly. So at the end of every year, the 4th quarter's interest we considered as the yearly interest, and we had written it for every year, that is for 5 years. In this particular case, we had 3 different banks stored in a data set. We had the rate value stored in the data set, and the interesting fact in this case was this 5,000 for 5 years was invested in 3 different banks which were giving 3 different rate of interest, and we were asked to calculate the earning at the end of 5th year, investing in all these 3 different banks. So the most important statement according to me in this program is this line where you are resetting the capital to 0. If you don't do this, then in that case the first bank's 5th year's capital will be carried forward when it starts calculating the interest, the 5th year's interest for the second bank. So these amounts that you see very close to each other will vary a lot if I don't write capital is equal to 0. Let's quickly cross check this. So I execute this data step. So as you see, this is 27,519, this is 59,834, which is absolutely unreliable. Then this is 98,054, which is again, not something on which one can rely on. So if you don't reset that capital to 0, this problem is going to occur where it is going to retain the interest or the capital gained from the first bank at the end of 5th year and used while calculating this amount for the second bank. So you have to ensure that when it starts a fresh calculation, that is for a new observation, this capital is set to 0. So with this we completed our topic on loops. Now we'll see the next topic, which is concept of arrays. And mostly in SAS environment, when we implement arrays, loops are used to iterate the elements of the arrays, process those elements and print them in the result set window or redirect them to the output data set. So we'll again see demonstrating or implementation of loops, but then they'll be applied on something called as arrays. So let's see how to make use of arrays first, and then how to iterate array elements with the help of loop and process and write them to the output data set. So we have a data set, input data set called as employee underscore donations. Let's proc print and see the data set. So I say proc print data is equal to Orion dot employee underscore donations, and then I say run. Let's print only variables which are employee ID, quarter 1, 2, 3 and 4. So I just say var employee ID and I say qtr1 to qtr4. You can take the shortcut. As you see, all these variables quarter1, quarter2, quarter3, quarter4 have consistent names and same constant prefix. We can take the shortcut where we can say qtr1 hyphen qtr4. That will automatically include 2 and 3. So I clear this, the output window. So these are the variables that I have in my input data set. Now if you see in this data set, these are the employee IDs and these are the contributions or donations by these employees. So this employee, if I just scroll this up and take you to the first row, if you see, this employee hasn't donated any amount in quarter 1, not in quarter 2, not in quarter 3. He donated some amount in quarter 4. Whereas this employee has donated some amount in every quarter. Same is the case with third employee. Fourth employee has donated in first 3 quarters and hasn't donated anything in the last quarter. Fifth employee has donated again in every quarter. Let's say on these employee donations, company is giving a supplement of 25%. So company is adding 25% from their side, and that is added to this employee's contribution. So what we have to do in this particular case is create a new data set which should have the company's proposed supplement, that is 25%, and the employee's individual contribution, and write it to a new data set. We'll first try to achieve this in a normal manner, and then we'll introduce array concept and we'll see how to iterate arrays using loops. So I'll write a data step where I'm going to calculate 25% of all these amounts or contributions, add it to the original value and write it to the output data set. So I say data EMP donation, then I say set employee underscore so I say Orion dot employee underscore donations, and then I say qtr1 is equal to qtr1 plus qtr1 into 1.25. Or I can simply say qtr1 is equal to qtr1 into 1.25. Then I say qtr2 is equal to qtr2 into 1.25. Then I say qtr3 is equal to qtr3 into 1.25. Then I say qtr4 is equal to qtr4 into 1.25. Okay, so it's like 125% of these values is what we need to write to our output data set. And then we say run. So execute this. Clear the output window. Clear the log. And I say proc print data is equal to EMP donation. Let me restrict the number of variables returned to the output data set by saying keep employee ID and QTR1 to QTR4. So execute this. Before this, since we have modified the data step, so if you see this, this is what we have computed. If you remember, for the first employee, we had Q4 donation amount as 25, and then company gave 25% of that contributed amount, which was 6.25. So 25's 25% is 6.25, which was added to 25, and that's how this was calculated as 31.25. These amounts were 15 in every quarter. So SAS has computed 25% of 15, which is 3.75, and this was added to the employee's contribution, which was 15, and that's how it has obtained this 18.75, 18.75, 18.75 in all 4 quarters. So here we have correctly computed this contributions, but if you see, there is lots of redundancy in our code. So we are writing a similar business logic several number of times. Instead of doing this, this could be easily done in a array and loop implementation. So instead of having this redundancy in your business logic, you can store all these elements Q1 to 4 in an array and iterate that array with the help of a loop, and you can easily compute these contributions just by specifying one line of code. So let's see how to convert this demonstration where we haven't used or implemented any array and loop with the help of arrays and loops. So let me show you how to create an array, and then we'll use that array, pass that array to a loop, and instruct the loop to iterate, calculate, and write the elements to our new data set. So an array is declared with the help of this keyword array. So array is basically collection of elements. This is not a unique concept in SAS. This concept was introduced ages back in programming languages like C, C++, Java, etc. So we have this array concept in almost every programming language, so in SAS, and the purpose of this particular concept array is somewhat similar in all programming applications and wherever we see this array implementation. So array is basically a kind of container which contains elements of similar type. So in case if you are handling a business scenario where you need several numeric variables or you need several character variables, instead of declaring those variables individually where you have to introduce lots of unique names, you can make use of an array and make that array equivalent to 5 variables or 10 variables or 100 variables or 1000 variables. So there are several advantages of arrays. Unlike normal variables which are scattered in memory, array variables are stored adjacent to each other in memory, so their retrieval time is less compared to the normal variables. Second, in case of normal variables, I'll have to introduce n number of normal variables to contain unique values, Whereas in case of array, it's just one name that you need to specify, which will act like 5 or 10 or 100 or 1000 variables. So you can avoid lots of variable names by introducing this array concept. Like this, there are several advantages of arrays, and in SAS, if you want to create an array, declare an array, we declare that with the help of this keyword array followed by the name of the array. Say for example, if you want to store those employee contributions, that is quarter 1, 2, 3 and 4, we can declare an array and name it, say, contrib. Then you start a curly bracket and specify the dimension of the array. This is called as dimension of the array or size of the array or length of the array. And then you specify the elements that you want to, or the variables that you want to assign to this array. So in case if you want this array to refer to quarter 1, 2, 3 and 4, you must say quarter 1 space quarter 2 space quarter 3 and space quarter 4. This is one way, or you can declare it like this. You can say array contrib and you can say qtr1 hyphen qtr4, or you can declare the array like this. You can say array contrib. If you are not very sure that what is the appropriate length for this array, you can pass this symbol star in place of the array dimension. So this is how you declare. You say array contrib star and then you specify qtr1 hyphen qtr4. So in all these three cases, we have declared the same array using three different syntaxes. In first case, we passed all the variable names that we wanted to assign to array explicitly. Whereas in case of second, we have taken this range like format. So we have set qtr 1 to 4, which will automatically refer to 2 and 3. In third case, we were not very sure that what is the appropriate length of the array or dimension or size of the array. So we just declared it using star and then we are supplying this 4 elements to our array. Risk when you pass the size or dimension of the array is you cannot pass more than that specified size or less than that specified size to this array. So in case if I am creating an array with dimension 4 or length 4, I cannot pass 3 elements or 5 elements. In case if I pass 3 elements, I am going to get an error saying too few elements. If I pass more than 4, that is 5, then I am going to get another error saying too many elements. So to be on safer side, okay, many a times we declare the array with this star symbol where you can pass any number of elements. So in all these three cases, we have declared an array which is numeric type. In case if you want an array which is character type, then this is how you need to declare it. So I say array country and I specify some dimension, say 5. I want this array to be character and length of every element that I am going to assign to this array should not be more than 2 characters. So I say array country, then in curly brackets 5 and then you say $2 and then see in previous case we assigned variables to our array elements. In this case, suppose I want to hard code my values. So I can say array country, dimension of the array $2 and in parentheses I can pass the values that I want to assign to this array. So I can write this country codes, say AU and then US and then say Canada, India and so on. So you can pass the elements like this. So in this particular case, your array dimension is 5. It's a character array because you have written $. This 2 represents the length of each element that you have passed to this array. So as you see, all these character elements that I have passed are of 2 characters long. So this is how you create an array and hardcode the array with some elements, some numeric values or character values. Now we'll rewrite the previous demonstration and implement it using arrays and loops. Let's see how to do this. So I'm marking this as comment, and let me write the actual code where I say data, emp donation, emp donate, then I say set Orion dot employee underscore donations, and then I say array, specify the name of the array, say contrib. I specify the dimension of the array as say 4, and then I assign my 4 variables quarter1 to quarter4 to this array. Now let me use a loop to iterate over this array. So I say do I is equal to 1 to 4 contrib of I is equal to contrib of I into 1.25. That's all, and I say end. Run. And let me write an output here. That's all. So this is how you need to create the array. You say array contrib 4 quarter1 to quarter4, do I is equal to 1 to 4. This is the loop which is going to iterate over my array. I say contrib I is equal. So if you create an array saying array contrib 4, there are 4 array elements: contrib 1, contrib 2, contrib 3 and contrib 4. Now in this particular case, contrib 1 is referring to quarter 1, contrib 2 is referring to quarter 2, contrib 3 is referring to quarter 3 and contrib 4 is referring to quarter 4. When you say contrib I is equal to contrib I into 1.25, this is like contrib 1 is equal to contrib 1 into 1.25. Contrib 1 is quarter 1, so this is like quarter 1 is equal to quarter 1 into 1.25. And then this loop will increment to 2, and this will be like contrib 2 is equal to contrib 2 into 1.25, which is quarter 2 is equal to quarter 2 into 1.25, and then 3 and then 4. So this becomes exactly similar to our previous demonstration where we computed this quarterly contributions like this. So if I execute this code, this output is not needed. This output is not needed because we have 124 observations, and this is going to calculate for 124 observations. Once it completes calculating this quarter 1, quarter 2, 3 and 4 amounts for the first observation, it will automatically write it to the output dataset the moment it hits the step boundary, and then go back to the input dataset, read the second observation and do the same for the second observation. So you don't need that output statement, explicit output statement. So I execute this once again, and now if I proc print, and say proc print data is equal to emp donate and run, let me restrict the variables. So I say keep employee ID and Q1 to Q4. I proc print this. So as you see here, this output is exactly similar to the previous output. So if I take you to the first observation, I remember the fourth quarter calculated amount in first observation was 31.25. In second observation it was 18.75 throughout. So same calculations are happening, but as you see this business logic is far better than what we implemented earlier, where we had lots of redundancy in our code. So we introduced array, we stored all 4 elements on which we wanted to perform calculation in an array, and then with the help of the loop we iterated over those elements, calculated the desired amount, and we had written it to the output data set. Now same thing can be done without specifying the dimension of the array. In that particular case, when you are specifying the stop value for the loop, nobody expects you to count the elements manually and then specify the stop value. Rather, we have a function which can count the elements of your array and use that value as the stop value for the loop. So let's write a demonstration, the same demonstration, but without specifying the dimension of the array. Instead of the actual dimension value, we'll specify star and make the array dynamic, and then we'll see a function that will calculate the length of the array, which will be substituted here and used as the stop value by the loop, okay, and implement the same business case. So I say data, say emp donate or emp contribution, then I say set Orion dot employee underscore donations, and then I say array contrib. Instead of 4 I specify star, and then I assign my elements as Q1 hyphen Q4, and then I say do I is equal to 1 2. Now here in this case it is easy for us to calculate the number of elements, but in production environment at times you'd be declaring arrays which will have n number of elements, which will have 100 or 500 or 1000 elements, and it is not feasible or rather possible to count manually those elements and use the number as the stop value for your loop. So in this particular case, what you can do, there's an array function called as dim. If you remember, in our previous session we discussed lots of functions. There is also a function or a category called as array functions, where we have this function dim, which can easily count or return the length of the array for you, that you can use as the stop value by this loop. So I say do I is equal to 1 to dim of contrib, where contrib is my array name. So this dim of contrib will automatically return the length of the array which will be used as the stop value by the loop. Now I say contrib I is equal to contrib I into 1.25. Then I say end and run. I clear my log window, execute this data step once again. We are getting some error. Say okay, there's a mistake in the library reference name. The dataset is created with 124 observations. I say proc print data is equal to emp contrib and then run. Here I say keep employee ID and qtr1 to qtr4. Execute this and proc print. So as you see, I'm getting exactly the same output again by specifying star instead of the actual array dimension, and then using the function dim to calculate the length and use that length as the stop value in my loop. So please remember, in scenarios where you are not very sure how many elements you are going to store in your array, you better declare the array with symbol star, like a dynamic array, and then you can pass any number of elements, and then to iterate over all those elements, ensure that you count the length not manually but using this function dim, where you pass the array name. This will return the length or dimension of the function which is used as the stop value by the loop and calculated this amount. So this was a quick introduction of arrays. We'll see some more business scenarios and try to master this concept of arrays in SAS.